Let's start solving maximum subarray sum. Okay, the problem statement says given an integer array ARR, you need to find and return the maximum sum possible from all the subarrays. All right, so suppose you have this example given here consisting of these elements 2, 3, -8, 7, -1, 2, and 3. Okay, this is an array which is given to you. Now, if you want to categorize a subarray, well, subarray is nothing but a contiguous chunk of your original array. Okay, and your complete array can also be considered as a subarray. All right, so if I say that this part 2, 3, and -8, is it a subarray? Yes, that is, because it is a continuous chunk of your array. Considering this one, this is also a continuous chunk. Let's say considering this one, a continuous chunk. What cannot be considered? Let's say if I say whether with 3, -8, and -1, can you consider this a subarray? Well, no, that is something different. That is subsequence, and we are not talking about that. Okay, we cannot skip any element in between. So you should keep this in mind. Now, what is the question saying? The question is saying that you need to give a subarray which has possibly the maximum sum in the complete array. So here you can see, let's suppose, let's try to make our own subarrays. Let's consider this one. Okay, what will be the summation of the elements of this chunk of the array or this subarray? It will be 5, -8, that means -3, correct? And -3 is supposedly not the biggest value that we can achieve while summing up and choosing our maximum subarray. So yeah, let's skip this. Skip this subarray. Going on to any other example, let's take this one up. What will we get? I'll get 5 - 1. That would end up at 4. 4 is still a decent answer. At least it is not negative, but is it the largest? Well, it turns out that this answer says that okay, it is not. But once you include 7 in your answer, this chunk or this subarray will become the maximum subarray which is required in the question. So here you can see, if we solve it, it says 11 as the answer. Okay, that is what is given as the output. And we need to focus on the output. We do not need to actually give the subarray, we need to give the sum of it. There are a few more cases mentioned here. You should take this under consideration. Okay, there could be a possibility that your complete subarray, that a complete array that you have may only consist of only negative numbers. Then, well, any subarray you try to make is going to end up in a negative, negative summation, correct? So in that case, what do we need? We must choose the biggest value possible, which means here in this case -2, and we should return that. In this case, last case in which no negative number is present there. Well, if there is no negative number and you are looking for finding maximum subarray sum, then you can always take the complete array as the subarray. None of the numbers would be negative, and complete array that you take would be adding up to the maximum subarray. In this case, yes, you can see 25 is the answer. Now let's try to discuss the approach 1. Well, in this one, we are talking about brute force only. Consider you have this array. What you will do? You will try to make up all the possible subarrays, correct? And how do you do that? Well, let's suppose we have an I loop, and you hold your I here at this 2, and then you run your j from this point till the end, making all the combinations up. Okay, like first one, you're going to make 2, 3, then it will be 2, 3, -8, 2, 3, -8, 7. Okay, these are all the subarrays that you're making, or you can like simultaneously count the sum of it. And what you need to do is, once you're counting the summations of all of the subarrays, and you need to keep the track of your maximum. Okay, so all the summations you are encountering, just keep the track of them, track of that in a variable, let's say result, and eventually once you are done with making all the possible combinations and you are like done with going through all of the subarrays, that means your I has moved till the end, and at every ith iteration you were moving from that point till the end with the help of your jth loop. Okay, so once the situation is like this, well, it is going to take a lot of time, correct? Because we are doing order of n operation, order of n times. This will end up at order of n square. And we are not taking any extra space, so the space complexity still is order of 1, but we cannot consider this one. This is not what the question demands. We need to move ahead towards a better solution. Let's go to this algorithm. Okay, the approach 2 will be done using Kadane's algorithm. What does this algorithm say? Well, in this algorithm, we only go like from the beginning of the array till the end of the array on once. Okay, so it will be performed in order of n. We will see the procedure now. Well, at that like at this point, every element that you consider, you need to consider that it is like that element is being included in your subarray, and you are counting your maximum subarray. Okay, the maximum sum of your subarray, including this number. What do I mean by that? Let's try to run it. Here you can see initially you don't have any array yet, right? So you have to consider this one. You considered this one. All right. Now, what are we going to do next? Well, every time we are going to choose a next value, let's say we are choosing this 3, we need to ask ourselves, so far, the biggest sum that I've got of subarray is 2, right? Adding this element up would be increasing this value, the maximum ending, would be increasing the maximum ending, or would it be not contributing to it? If it is not contributing to it, then what will we do? Then simply we would begin our new array from here. We need to just check that at every ith point that we are going to choose, including that element, including that as the max ending element, what can be maximum subarray formed there. All right, so now that I've got the point, this is how we are going to do that. Okay, we are maximizing our maximum ending variable. Okay, here we have maximum ending plus ARRI. Our first choice is to include this element. If this is resulting in a bigger value than our current maximum ending, then we are going to consider that. Otherwise, we will consider this element and we'll try to form a new subarray solution from here. So here in our case, you can see 3 is included. Maximum ending so far is 5, right? So far it is like till here it was 2, now here it is 5. You must also keep in mind that we are keeping the track of the result. We are maximizing it. Including one more value here, what will we get? Well, here our maximum ending will become -3, because if we are including this element, then it is going to be -3. Is -3 bigger than 5? Of course not. That is why my result is not getting updated. It is being retained as the previous value that we have. Now, once we try to include one more value, this 7, now you can tell me that whether, like, what is a wiser choice? So far, my answer is -3. Maximum ending till this point was -3. So doing -3 plus 7, is this bigger, or 7 individually is bigger? Okay, of course 7 individually is bigger, right? So we are going to now consider 7 as a maximum ending. Okay, till this point I'm only taking this subarray, which adds up to 7. Thus from this in this particular point, my maximum ending will become 7. Now once that is done, again let's try to proceed with our solution. Now seeing the case with -1, I will include -1. So maximum ending till this point would become -6. But make sure we have gotten a new big answer, result 7, which is stored in the result here. Now, including 2 here, what do we have? We have maximum ending as 8. Now, previously I stored 7, but I received one answer which is bigger than 7. I updated my result 8 here. Okay. Then, similarly, again I have to include this value 3. So far, I have the answer as 8. So what is bigger? 8 plus 3 or just 3? 8 plus 3, of course, right? So this chunk will be considered, and at this point my maximum ending would become 11. And the result, because like previously it was 8, now we have gotten a bigger result or bigger maximum ending. I'm going to maximize my result and I will get my result as 11 eventually. Okay, the iteration is now done. We have successfully traversed the array, and our maximum ending is giving us the desired output that we have of maximum subarray sum. All right, let's quickly see the code for the same. So here you can see what we are doing. We have our two variables here, result and maximum ending. We have initialized it with the first value of our array, and then we are iterating through this loop. Okay, only for once. That means order of n n times in terms of time complexity. Okay, what are we doing? Every time I'm seeing that whether maximum ending that I've calculated so far plus ARRI, the current value, whether this value is bigger or the ARRI individually is bigger. In this case, like in either of the case, whatsoever is the bigger value, I'm going to make that my new maximum ending. Either it could be including a value or it could be starting a new subarray. All right, once that is done, I also have to maintain the track of when I'm getting like bigger values of maximum ending, I should store that as result. Okay, so once I have successfully executed my traversal, eventually I will return my result here at this point. The time complexity for this solution is going to be order of n, and we are not actually using any extra space, right? So the space complexity would turn out as order of 1, constant space. Okay, let's try to run this code now. Okay, here's the code. Let's try to compile and run it. Okay, it is giving us the desired output. Now let's try to submit that and see if it is working with all the test cases there. And yes, it is passing all of the test cases those are mentioned. So I hope now you have gotten the approach of the question, and if you still have any doubt, do try to dry run the solution once more. And if you like the solution, then do tell me in the comments. Thanks.